Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the January 2016 Algebra 1 Common Core New York Regents exam. Just for your information, this is a detailed coverage of the concepts. The goal here is to make sure that you understand the underlying concepts behind the question so you can do well on the upcoming test. If you'd like to do a real quick coverage of the solutions to this problem, you can fast forward through parts of this video or just click on this link here for worked out solutions to gain access to the transcripts. Alright, let's take a look at question number 1. It reads, in the function f of x equals x minus 2 quantity squared plus 4, the minimum value occurs when x is... So one thing you want to note as indicated here is that if you're given a quadratic function in standard form, ax squared plus bx plus c, the x value of the extrema, max or min, can be determined by simply computing negative b over 2a. Okay? On the other hand, if you're provided the quadratic function in vertex form, x minus h squared plus k, then the maximum or minimum, the x value of that can be computed by determining what the value of h is. Okay, so let's take a look at the function we have here. We have f of x equals x minus 2 quantity squared plus 4. Now, what form is this? Is this in the standard form, ax squared plus bx plus c, or is it in vertex form, x minus h quantity squared plus k? We can clearly see that it is in the vertex form. So all we need to determine is the value of h, and that will tell us what the extrema is, the x coordinate of the max or min. All right, so we have f of x is equal to x minus h quantity squared plus k. Now, can you see what h is? H is what you're subtracting from x, right? So you have x minus h, you have x minus 2. So we can clearly see that h is equal to 2. All right. Now, we know that it is a minimum because this is positive, so we have an upward opening parabola. So we're looking for the x value of the minimum, okay? So since h is 2, what does that follow? It simply tells us that the minimum value occurs when x is what? X is equal to 2. Okay? So your answer is option number 2. Now, what do you think 4 represents? This is just an additional detail. 4 represents the minimum value itself. Okay, the minimum value of 4 occurs at x equals 2. So you got to be really careful to read the question carefully to make sure you understand exactly what it's asking for. Is it the value or where the value occurs at? Okay, so the value, the minimum value is 4. So minimum value 4 occurs at x equals 2. Okay, and that is basically the coordinate of the vertex. The vertex of this parabolic function right here has a coordinates 2, 4. Okay, the value is 4 and it occurs at x equals 2. All right, let's take a look at question number 2. Number 2 reads, the graph below was created by an employee at a gas station. So we have this graph below. So the question is, which statement can be justified by using the graph? Now, one thing you want to recall is that whenever you're computing a change in the x-axis divided by the change in the y, what you're looking for it's the slope. Oh, I meant to say the change in y. So change in y divided by change in x is the slope. Okay, so in this problem, this is basically your x-axis, your run, and this is your y-axis, your rise. So Any measure that involves computing change in cost divided by change in gallons, or cost per gallon that's alluding to the slope, rise over run. Okay, let's take a look at problem 1. Option 1, it says if 10 gallons of gas was purchased, $35 was paid. So problem 1 is an evaluation problem. What it's asking you to find is the statement f of 10 equals 35. Is it true or false? That's what the statement is saying. Okay, so remember, gallons is the input. So if I input my gallons into the function, do I get an output of 35? Okay, so let's go to the graph and see if this statement is true or false. So I'm going to trace from my input, which is 10 gallons, to my graph right here, and then I'm going to trace it to the output. Now, what makes this statement true? This statement is true if our output lands exactly on 35. Is that the case here? Absolutely not. We can see that f of 10, if 10 gallons was bought, then the amount paid is somewhere around $37, or we can say, yeah, $37, $38, and that clearly is not equal to 35. All right, so what does that tell us? The first statement is false. Okay, in order for it to be true, the output had to fall exactly on 35. Now let's take a look at option 2. It says for every gallon of gas purchased, $3.75 was paid. And even if you look at option 3, it's the same format. For every 2 gallons of gas purchased, $5 was paid. So these two problems, you're looking at gallons divided by cost. Okay, that's what for every means. You're basically dividing. So these two options have to do with the slope. All right, so we just have to compute the slope of this line and then see which of these ratios in reduced form we end up with. Okay, so let's consider option 2 first. So option 2, we're looking at the slope. How do you calculate the slope? The slope is rise over run. In coordinate form, it's y2 minus y1 divided by x2 minus x1. Okay, so in order for us to calculate the slope, we need 2 points. Now, when you're given a coordinate system like this on a graph, you want to pick the points that lie on the graph and are lattice points too. Okay, what are lattice points? Lattice points are points that lie on the intersection of the graph and the x and y coordinate grid. Okay, so those are the beautiful points that you can pick without making mistakes. So take a look at 415. This is a lattice point right here because it's on the graph, a point on the graph, and it falls on the intersection of the grid. So we have a nice coordinate here. 6, is this a lattice point? No, it falls on the y line. I'm sorry, it falls on the x coordinate, but it doesn't fall on a y coordinate. So we don't know exactly what the y value is here, so our answer will not be that accurate, okay? But take a look at this point, point 8, 30. This is another lattice point. It falls on the graph, and it falls on the intersection of the horizontal and vertical coordinate grid. All right, so you have to be very selective on the points that you pick so your calculations come out to be correct. Okay, so what we're going to be doing right now is calculating the slope on this triangle right here, the rise divided by the run. So this is your run right here, and that is your rise. Okay, since we're using coordinates, all we just simply need to do is extract the coordinates of these 2 points. So this point right here is 415, and then the other point here is 830, and then just use those points, right? So the points we're selecting, let's write it down. So we're going to pick, the first point is 415, and then the second point is 830. So our first point tells us x1 and y1, and then our second point tells us x2 and y2. So all we'll simply do is plug in these values into the slope formula and see what we arrive at. Okay, so the slope, y2 minus y1 is 30 minus 15 divided by x2 minus x1, 8 minus 4. Okay, when you subtract this, you have 15 divided by 4. And to answer option 2, we're looking for every gallon, so we want to divide it completely, write it in decimal form. Okay, so you want the denominator to be 1 for every 1 gallon. Okay, for the second one, we'll have to divide by 2. So if you plug this into your calculator and divide it out, 4 goes here 1, 4 goes into 15, 3.75 times. So your answer is going to be $3.75. Now let's pause for a second. What does this tell us? 3.75 per gallon. It tells us that for every gallon purchased, you're paying $3.75. Option number 2 is correct. Okay, so there goes your final answer. If you wanted to test option 3, for example, you can simply ask yourself, okay, $5 is a rise because the y-coordinate, the y-axis, is the cost, and then the run is $2 because our x-axis is gallons, right? So if you do 5 divided by 2, that's the slope. Okay, rise over run, and then if you reduce that, you can end up with 250. Okay, and that is not the slope of this line. The slope of this line is $3.75 for each gallon. So we can clearly see that option number 3 is wrong. Okay, all right, let's take a look at problem 3. It says for a recently released movie, the function y equals 119.67 times 0.61 to the x models the revenue earned y in millions of dollars each week x for several weeks after its release. Based on the equation, how much more money in millions of dollars was earned in revenue for week 3 than for week 5? So the word we're looking at here is more. How much more? Okay, we're comparing two outputs, but the word more tells us what operation to use. Okay, if you want to see how much more one measure is compared to the other, you have to subtract. Okay, so what are we subtracting? We're subtracting the revenue for week 3. So y, the function evaluated at week 3 minus the y evaluated at week 5. Okay, so this difference would tell us how much more revenue was generated in week 3 compared to week number 5. Okay, so how do we know what y3 and y5 are? We're simply going to use the provided function. Okay, the function, the exponential function y of x is equal to 119.67 times 0.61 raised to the x power. Okay, now this problem is also assessing your ability to make accurate use of your calculator. All right, so let's go ahead and evaluate the two. So we start with y of 3. Okay, what is y of 3? It simply means that wherever you have x in the function, you replace it with the input value of 3. Okay, so 119.67 times 0.61 raised to the what power? Raised to the third power. So there goes your input. Okay, so we're going to plug that into the calculator and figure it out. We're also going to evaluate y at the second time period, which is 5 weeks. So y of 5 will be computed too. So 119.67 times 0.61 raised to the 5th power. All right, let's calculate what these two are, and then find the difference, and then we'll see how much more we have in week 3 compared to week number 5. Okay, I'm going to be using the TI-89 calculator to carry out this evaluations. So we have 119.67. The syntax is the same with other TI 80 plus calculators. Okay, so just enter it just like this, 0.61. Now, if you want to exponentiate, the caret button helps you gain access to the exponential field. Okay, so use the caret button, and then your input value is 3 for the first one. Enter, and then the second entry is 119. I can just simply call up the other entry by pressing second function enter to save time, and then change my 3 to 5, press enter. Okay, another way you can do it is just enter both of them together and subtract it, but I like to play it safe, so that's why I enter them separately to make sure I don't make any mistakes. Okay, so what I'm going to do is just subtract y3 from y5. Okay, if you're entering it with the other TI calculators, you can just enter it to 4 decimal places and you should be able to get the correct answer. Okay, so let's go ahead and write down our results. So we have 20. Let's change this out. So for y5, we have 27.1628 to 4 decimal places, and that's y3, sorry, and then y5 is 10.1073. Do not round your answers. Do not round intermediate results. Okay, you want to round at the end so you don't make mistakes with your accuracy. Okay, so now we have these two. We're going to compute y3 minus y5. What is y3 minus y5? You simply subtract these two results you got, right? y3 is 27.1628 minus y5, which is 10.1073. And then our answer is 17.0556. The options are rounded to the nearest hundredth or the second decimal place. So we want to round ours. If we round it to the hundredth place, right here, the number behind it is 5 or greater. So we just add 1. We carry 1 over. So our difference is going to be 17.06. Okay, this is how much more revenue you had in week 3 compared to week 5. Of course, is in millions of dollars. So answer is option number 3. All right, let's take a look at question number 4. It reads, given the following expressions, which expressions results in an irrational number? Okay, so one thing you want to note is what a rational number is. So if you see qualities that do not fit any of those descriptions, then you know that the number, more likely than not, is not rational. Okay, so a rational number could be a whole number like 1, 2, 3, 4. Whole numbers and their opposites, basically the set of integers. It could also be a repeating or a terminating decimal. Okay, so in decimal form, either it's repeating or you see the same pattern repeating itself over and over again, or you terminate, it stops after a certain number of numerical decimal places. All right, you can also have a quotient, sum, product, or difference of integers. So if you're dividing whole numbers, multiplying them, subtracting them, you're always going to end up with a rational number. All right, and then lastly, if you're taking the square root of a perfect square, you will also end up with a rational number. All right, so what we're going to do is take a look at these choices we have here and see which one fits this description, and then we're going to eliminate that. Okay, we want the ones that are not rational. So option 1, negative 5 over 8 plus 3 over 5. What do we have here? The numerator and the denominator are integers. So this is a rational number. The numerator and the denominator here are integers. So remember, 3, the quotient, okay, of any of these types of numbers is rational. So for option 1, we have a sum of two rationals, rational plus rational. And guess what? Anytime you add two rationals together, you always end up with a rational. All right, so option 1 is not irrational. So we can eliminate option 3 because it has 1 in it. Let's move on to option 2. We have 1/2 plus root 2. 1/2 is a rational number because we have an integer on the top and the bottom. So quotient of two integers is rational, according to point 3 in our notes. And then what is root 2? 2 is not a perfect square. Okay, you can't think of an integer multiplied by itself to give you 2. So since this is not a perfect square, the radicand, root 2 is irrational. Okay? Now guess what? If you add a rational and an irrational, you always end up with an irrational result. That always happens. Okay? So this is one of the numbers we're considering. So option 2 is irrational. Okay, now we can eliminate that. So our answer is either 1 or 4. So let's test one more. Okay, let's test option 3 to see what's going on here. If option 3 is not irrational, then our answer will be number 1. Okay, so what is the square root of 5 times the square root of 5? Now, you want to be careful here. Whenever you multiply two irrationals, so let's look at root 5. 5 is not a perfect square. If you square all the numbers less than half of 5, you're not going to end up with 5. Okay, so 5 is not a perfect square. So when you take a square root of 5, it's an irrational number. Okay, so this is irrational times irrational. Now, whenever you multiply two irrational numbers, your answer could be rational or it could be irrational. So you don't know. The product doesn't specify. You don't know exactly what the result is. So it could be irrational or rational. So since there's no rule on the product of rationals, we actually have to work the problem out. We don't have any shortcuts here. Okay? So root 5 times root 5, how do we evaluate this product? You simply multiply the radicands, okay? So you're going to have root 5 times root 5 is root 25. Is the radicand a perfect square? It absolutely is. So what does that mean? Look at note 4 here. Item number 4 in our notes. If the radicand is a perfect square, then the square root of that perfect square is a rational number. Okay, what's the square root of 5? Of 25, it is 5. 5 is what? Rational. Okay, so by evaluating the results of multiplying these two radicals, we were able to determine that the product is in fact rational. Okay, so is option 3 irrational? The answer is no. So we eliminate option 4. Our final answer is option number 1. That is the only irrational number we have here. Okay, and even if you look at option 4, you can clearly see that 3 times root 49 is rational because the radicand is a perfect square. Square root of 49 is 7. Rational times rational, guess what? Is always rational. 3 times 7, 21. That is a whole number. And that's a rational number too. So we don't want that. We don't want that. We don't want 1 or 3. We only want the irrational number. Okay? Now, another way you can do this is by plugging these values into your calculator what you find out is that only option 2 will be non-repeating and non-terminating. Okay, let me just show that to you real quick. So if I enter this into my calculator, I do 1 divided by 2 plus the square root of 2. If the decimal expansion terminates or repeats, then it is rational. Okay, but let's see what happens. Enter. Bam. You see that? If I highlight that and bring it down, what do you notice? The decimal point just keeps on going, and there's no discernible pattern here. Hence, this result is irrational. All right, let's take a look at number 5, the last one in this review installment. It says, which inequality is represented by the graph below? Now, I have a little list here. It basically tells you that if you have y isolated in the graph of a linear inequality, as is the case here, remember y has to be isolated. If you have y isolated, the inequality can easily help you determine what the correct answer is. Okay? If you have greater than or equal to, it tells you that the line is going to be solid and you're going to be shading up. If it's less than or equal to, the line is going to be solid and you're going to be shading down. Remember, less for down, greater for up. If it's just less than, it's going to be a broken line shade down. If it's greater than, it's going to be a broken line shade up. In this problem, we see that we have a solid line. So all our inequalities must have the inclusion bar. You see this little bar right here? Has to be present. If we had any option that didn't have that line there, guess what? We eliminate it because it's not going to be a correct answer. All right? So it's a solid line. All of these inequalities are all solid. Okay? Now the next thing we're looking at is the direction of the shading. Since we're shading above is greater than. Okay? Below is less than. So let's look at the options we have here. We have a less than, eliminate that, and then we have a less than, eliminate that. It has to be greater. Okay? Now, how do we know which one is correct? It's either option 2 or option 4. From left to right, the line is going up from left to right. What does that tell us? That tells us that we have a positive slope. Okay? So since you're going up from left to right, we have a positive slope. Our answer is option number 2. Okay? So just to help you see for sure that this is a correct answer, let's verify what the slope is. So how do we find the slope when you're given the graph of a line? What you do is you pick 2 points, 2 lattice points. We talked about this earlier. 2 points on the line that falls on the intersection of the coordinate grid. That's a good point right there. That is another good point. Now we just compute rise over run. We don't have to use a formula here. Okay? So the slope, m, is rise over run. What I'm trying to show you is that we are going to have a positive slope. Okay? All we care about is the sign because option 4 has a negative slope. So our run is 1. You go 1 unit to the right on your slope triangle. So our run is 1. And then to rise up to that point, we go up 2 units. Our rise is 2. Okay? So we have a run of 1 and a rise of 2. So guess what? Our slope is 2. That's exactly what we have here. So that's why option 2 is the correct answer. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions, just post your question in the comment section below and we'll be glad to address it as soon as possible. More clips can be found on mathgotserved.com. Check it out. Thanks again for watching and have a wonderful day.